So continuing the conversation about the collision theory and activation energy, we get to one final equation, which is referred to as the Arrhenius equation, obviously developed by a gentleman named Arrhenius. He came up with a mathematical relationship between the rate constant and the activation energy. And here's the equation that he came up with. So the rate constant is equal to, what's this A? This we've seen before. But this A, what is it? It is a frequency factor. It is a number that represents the likelihood that collisions will occur with the proper orientation for a reaction. How do you figure out that A? Good question. What we do know is that as the activation energy increases, the rate constant actually decreases, because the fraction of molecules that possess that required amount of energy is going to be smaller. So reaction rates are going to decrease as you increase the activation energy. It's harder to get over that hump. There's fewer molecules that possess the energy to get over that hump. So the rate at which that reaction takes place is going to go down. So again, back to this frequency factor. It's kind of a hard thing to grasp. But if you take a look at this version of the Arrhenius equation, we can put it into y equals mx plus b format. Then you can graph it, and that frequency factor winds up being the y-intercept. So that's a little bit nicer idea to work with. In addition, we can take two sets of data and ignore that frequency factor altogether. You can use at various temperatures, figure out what the various constants are going to be. You can wind up being able to calculate the activation energy without needing to know that frequency factor. So if you have a couple of sets of measurements, you can use the Arrhenius equation in this version and ignore that frequency factor. Okay, so this video was only 2.5 minutes long, but we are done talking about the idea collision theory. Next video to come is going to be on actual mechanisms, but I don't want to start that here. I want to start it in a new video.